it's my honor to be invited. Uh, uh, my wife, Heather, is in the back row there, and we knew Barbara. So it's especially nice to be asked to speak in the Barbara Schlachter lecture series on a topic that I'm very passionate about. So I'm going to introduce myself. I like it when speakers give a little path to how they got to Iowa City. And I picked a weird map because this is the right audience for a weird map. This is the eco-regions or the ecological regions of the United States. I think it's more fun than a standard state map. And I grew up in the Erie Drift Plain in Youngstown, Ohio, a little blue area that has a red dot where Youngstown is. I have a photo of me and my siblings. I'm the little guy in the red jumper there. And a fact about Youngstown, I didn't know this when I was a kid, but it's heavily polluted. And it was, I knew this as a kid, it was a powerhouse of iron and steel. And when I was born, there were more than a dozen blast furnaces operating in Youngstown. When I went to college, there were 2. Youngstown collapsed in the early 1980s. The economy collapsed. Social services collapsed. Air pollution got clean, but that's because the plant shut down. So later on, I moved to the mid-Atlantic coastal plain, living in Annapolis and Baltimore, and I was the environmental engineer for an international paper plant. I didn't have a photo of it, but I did find a photo of the plant's demolition, sadly. It closed shortly after I left for graduate school and then was later demolished. So I managed air quality for this facility. It was the 3rd largest air toxic source in Maryland, which was one of the reasons it shut down because the pressure to control all those pollutants caused a lot of expense for the company that couldn't be sustained by the market. There were a lot of other factors too. Then I went to graduate school in the Western Allegheny Plateau, whose largest city was Pittsburgh. And I was at Carnegie Mellon, and I did a thesis in chemical engineering focused on atmospheric particles. And I was lucky enough to take these paired photographs where you can see downtown Pittsburgh really well on a clear day. And this is from the same vantage point, same time of day, but on a hazy, smoggy day where visibility was much limited. Then I made it to the Western Corn Belt Plains, which is the official title of this ecoregion. And y'all just gave me more air pollution. You lit your landfill on fire. So we went out and measured that to figure out what the chemistry of burning tires is, because that was a tire fire from the drainage layer of the landfill. And there were very few places where you could measure a lot of burning tires that wasn't in the lab. But we vacation in the driftless ecoregion, and that is that light green teal area. Its official ecoregion title is driftless area. So I like that. And there's my wife Heather. She's in the back row, and we were winter camping in the driftless about a month ago. So I've been at University of Iowa for 20 years. Oh, I forgot one other family photo. My 2 kids, The middle one is city high grad, and on the right is city high and scattergood grad. So my research group at the University of Iowa is in these 4 areas that you can read. And I have photos of many of my recent graduate students. I won't be talking about their work today because the prompt for today was climate change and wildfires, which is something I've personally been researching. We have 2 field sites. One that we've been running for 17 years in West Branch, measuring the concentration of greenhouse gases at the top of a television tower every hour for 17 years. And this is part of NOAA's global network to monitor greenhouse gas concentrations and trace gas composition in the atmosphere across the whole planet. And this is very useful for evaluating the models that people build to try to understand how the Earth's atmosphere and climate change are working together. And then in November, we installed something on the top of West High that looks at the sun or the moon, whichever is available, and does spectroscopy by looking at what wavelengths of light survive the passage from the light source to the atmosphere, to the sensor. And you can tell a lot about atmospheric composition from that measurement. And it's used for satellite calibration, because there's satellites going around the Earth that are doing the same measurement, but it's a lot harder from a satellite because they're looking at the reflection of sunlight off the surface. And there's all this geometry and it's a moving platform, whereas we have a nice simple setup where we can just point straight at the light source and have a lot of photons and sort of get the gold standard value. And then they do all their fancy geometry and math and test whether they can get what we get. This is number 246. There were 245 installed all around the globe before us. And this is one of my students setting up some equipment at the bottom of the tower. And I'm in the Department of Chemical and Biochemical Engineering. And this is just, I love this photo of our students at the national conference in November with one of my colleagues went along to the conference. And my last plug before I get started on the topic is a new certificate. University of Iowa offers 31 university-wide certificates. And the 32nd was just approved, and it's applied climate science and energy technology, and that will be the home of that certificate will be my department in chemical and biochemical engineering. So hopefully that will be live for students to enroll in starting this fall. We'll see. It might be spring 2025. So I have 3 messages today. I want to make sure everybody's on the same page in terms of air quality basics. And then we'll talk about how climate change and air quality go together. And then I'll end with win-win combinations that talk about air quality and climate. Any questions before I dive in? So 3 air pollutants I want to teach you about today, if you don't already know. The first is ozone. And I do have a little YouTube that I don't know if that causes any recording. Okay. So ozone is a colorless, does have an odor, but if you can smell it, there's too much of it. So at relevant concentrations, it's odorless. And it's a health hazard. And then there's fine particulate matter, which is the smoke and the haze and the particles that get in our lungs. And then if we're going to talk about particles and climate, we need to talk about pollen and aeroallergens because they're connected. So this video says the ozone story better than I can, so I'm going to play. So ozone is good in the stratosphere at 20 miles up, 30 miles up. There's a blanket of lots of ozone. And we need that to prevent strong UV radiation from killing all life on Earth. And then there's also ozone in at the surface. And there it's much lower concentrations, but it's not good to breathe. It's like supercharged oxygen. Normal oxygen is 2 oxygen atoms. Ozone has a 3rd atom. It makes it more reactive. When you breathe it, when it touches anything, it tends to break chemical bonds. And the bonds in your lungs don't like to be broken. So it's bad to breathe a lot of ozone. When ozone concentrations are high, Iowa DNR, EPA will issue an air quality alert. It happens a couple times a year, usually in summer. Anything people want to add about ozone?
What causes it? What causes it when it's high?
So it's combustion exhaust and organic compounds that are emitted from solvent use and fuel and from plants, from trees and shrubs. That all gets together in a sunny atmosphere and creates the chemistry that makes ozone. Great question. Thank you. So then the switching gears to the fine particles, which is the other thing you'll get an air quality alert about, they're really tiny. So the fine particles are the little red dots that are too small to be seen with the human eye. They're, a 60th of the width of a human hair. And they come from combustion and chemical reactions and sea salt spray and a little bit of dust. Most of the dust is big, but some of it is really small.
Excuse me.
Yep.
How about microscopic plastic particulates?
Yeah, micro and nanoplastic.
Yeah.
Are in this bin, and it's a new topic of research that's been around since the 40s and 50s and 60s. We're finding out by digging in the dirt and finding the microplastics. I say we, I mean the scientific community. Yeah.
It's also in the heart, in plaque in the heart.
Yeah, a big paper in JAMA last week showing little plastic particles in arterial sclerotic plaque in the carotid artery of people. So in this room, in a 1 cubic centimeter box of air, there's probably 5,000. I mean, they're running diesel equipment outside, so that probably makes it higher. There's probably 8,000 particles in a little box like this. And then in a box like this, from what I've read, there might be 1 or 2 microplastic particles. So there's not many of them, but we don't have natural degradation mechanisms. We can't chew them up in our bodies. So the health effects are really unknown and just emerging. So these fine particles have been shown by many different types of medical and epidemiological studies to have 2 things: long-term effects to mostly your heart, and short-term effects mostly to your lungs and respiratory system. So they're associated with heart disease, arteriosclerosis, acceleration of the bad symptoms from COPD and emphysema. And then the short-term effects, if you're out on a really bad day, there is a statistically significant increase in the number of heart attacks, asthma attacks, and lung infections. There's emerging research that's not solid yet, but there's suggestive evidence of links to neurodegenerative diseases like Parkinson's and Alzheimer's, as well as diabetes. And then it's not a maybe. There's definitely a link to low birth weight, preterm birth, and fetal development problems when the mom breathes a lot of fine particulate matter. So it's a big problem in the US and globally. And there's a warning system around these pollutants that's run by the EPA and also picked up by the state and the county health departments. And it's a 6-level warning system going from good up through once you pass 100, that's when people need to start taking action. And 100 is the threshold for unhealthy for sensitive groups. The sensitive groups are what you might think: children, pregnant moms, the elderly, and people with pre-existing lung and heart conditions. So if you want to know, you can go to airnow.gov, and there's an app, and there's a website, and it will put in your zip code, and it will tell you your air quality index, and then give you suggested actions based on it. There's maps available. This was from when the forest fire smoke hit New York City and Washington, D.C. in summer 2023, and they got a very rare thing for them, which was the maroon level of hazardous air quality. On the EPA website, there's a guide for ozone and a guide for particle pollution. And it's, color coded by the 6 levels and gives recommended actions. And when you hit 100, it says make outdoor activities shorter and less active. It's okay to be outside, but watch for symptoms, be mindful of your own health and how prepared you are to handle the ozone or the fine particulate matter that's out there. If we have time at the end, I have some pro tips, some things that I recommend to people that aren't in the EPA guide, so we can come back to that later. But I wanted to hit the thing I was asked to talk about: climate change and air quality. So ever since we've known that climate was changing, air pollution people have been saying, well, how is air pollution going to change in a changing climate? And there are 3 mechanisms for the change to happen. The weather can change, which changes air pollution, and that happens through winds, changes in the amount and timing of rainfall, changes in the amount and type and location of clouds, and changes to large-scale air movements. We're at this boundary where we get Gulf air sometimes, and we get Western US air sometimes, and we get Canadian air sometimes. And so they each bring different air quality with them. And if the fraction of Gulf air versus Western air changes, then we get a different air pollution environment. The second thing is the chemistry of the atmosphere is sensitive to temperature, just like any chemistry experiment. You want to redo it, do it 20 degrees warmer. You'll get a different result. And many atmospheric reactions are sensitive to water vapor, and the amount of water vapor is going to change with climate change. And then the third mechanism is climate change affects the soil and the plants and the amount of fire, and those influence air quality. So to summarize, we have our climate system, we've got our natural emissions that come from forests and soils, fires, and we have human activities that generate air pollution. And the challenge for the science has been, these are all coupled systems, and none of them are changing in isolation. So it's hard to do the study to say, well, you can ask, okay, 2050, air pollution will exist. Would it have been more or less severe if the climate was not changing? Right, but it's a hard study to do because of all these coupled changes. How much fire do you put in your 2050 simulation of air pollution? How much soil emissions do you put from that soil that you know is going to be a little warmer? Maybe it's going to be drier, maybe it's going to be moister. So it's difficult. And so there's a lot of uncertainty associated with the answer that I'm going to give you. For pollen and alloaerogens, every paper I found says it's changing. It's definitely changing. You can't change the climate without changing the plants and what species grow and how fast they grow, and the associated pollen and other allergens that they will release. Is it going to be worse? It's going to be location dependent. It's just going to be different. The allergens that if you don't move, the allergens that you grew up with will be different 10 years from now because the plant communities and the seasons are changing. The preliminary evidence says, yes, it will be worse. More pollen, longer pollen season, and the National Climate Assessment has regional sections, right? A Midwest chapter, and a Northeast chapter, and a Southwest chapter. And in the Midwest chapter, they say oak pollen is getting worse in the Midwest and will continue to in a warmer climate with more carbon dioxide because that feeds oak trees. So that's what I know about pollen. Yep.
You said oak pollen will be getting worse.
That's what,
When you say worse, exactly what does that mean? Is it the amount of pollen in the air, or the composition of the pollen, or the shape of the pollen? What will change in the oak pollen?
I just read the paper and it said more pollen.
So
I think
The
it
amount
was
of-
referring to amount.
the
So
amount of the pollen.
A lot of these early studies are just looking at the long-term trend in counts.
Okay. Okay, thank you.
How is that specific to oak?
I don't know.
So to what extent, I'm very naive, to what extent is pollen a good thing? And we're learning about the bad thing, but what does it do? What is it? Why do we want it? Why would we want all of it to disappear? That's a vague question.
I'm only speaking to its role as an allergen.
Yeah,
I can't speak to the larger ecological role of pollen in a warming world and, you know, pollinators. I'm a chemical engineer.
so it will be different.
Yeah. So moving to the second pollutant, ozone. Ozone globally is going to decrease in a warmer world. But in the polluted places, it's going to increase. And I have a map of places in the United States with official ozone pollution problems. And so, you know, Lake Michigan, Chicago, Milwaukee, St. Louis, Evansville, they're likely going to have more problems, right? It's going to be a bigger lift to clean it up. you have to remove the precursors, the combustion exhaust and the solvent and paint and fuel compounds. You have to crank down on the emissions of those. But the weather and the temperature on the high ozone days is going to be pushing against that. Yep.
So when you talk about things like solvent and stuff, are we talking about other kinds of chemical pollution like through factories and stuff? Is this factor into the whole climate change thing, or is that kind of a whole different topic, the pollutions that such as VOCs that make people sick and that sort of thing?
So the precursors to ozone are VOCs, volatile organic compounds, which are emitted by industry, by combustion processes, and most of the stuff you buy at the hardware store and the drugstore have some solvent or solvent-like compounds in them that can contribute to ozone. So all of that together, but globally, that's only 5% of what nature does. Nature emits 20 molecules of VOCs for every one that humans emit. And so is what Reagan famously said, the answer to air pollution is cut down the trees. And technically he was right, because they have such strong emissions. Arkansas is known as the isoprene volcano because the forests in Arkansas emits so much isoprene, and I should know what species, and I think it's oak that is so prolific with its isoprene emissions. But people design aircraft studies flying through Arkansas just to capture the emissions from the Ozarks. And a lot of our bad ozone days are under southerly winds, so we're getting all those VOCs from those southern forests. So the official line on ozone is less in remote places, more in polluted places, but the official line was very conservative about how much fire would change in the future. And so if wildfire in North America goes up, our ozone problem gets up, worse, because those fires emit VOCs and the other, it emits both of the precursors. And last summer, with all the smoke from the forest fires, was also a bad ozone year in a lot of places. So, and finally, the National Climate Assessment does think that ozone pollution will become more severe because of climate change. Now, it's getting less severe because we are cleaning up all these sources. It's just going to become, it's going to go down more gently, right? And you're going to have to take more actions to get those decreases. So the third class of pollutants was fine particulate matter, and I've just given the summary statement from the International Panel on Climate Change. They have a medium confidence that the effect will be small. It'll be positive, increases in some places, decreases in other places. But they also have medium confidence that the pollution extremes will become more extreme in a changing climate, because our heat waves are going to get more extreme. Our fires are going to get more extreme, our droughts, the whole hydrologic intensification is going to lead to sort of the peaks being peakier, even if the average doesn't change much in terms of dealing with these fine particulates. And then the third fact is we know that we're going to have compound events, just statistically. We're going to have air pollution episodes, but they're going to happen at the same time as a drought and at the same time as a heat wave. And so now you go outside, you've got to deal with the heat stress and the particles and the ozone that you're breathing during that event. So we need to be prepared for that. It always happened together. It's just going to happen even more together. So those are the summary statements. The why, how can it go up in some places and down in others? The climate change factors that cause an increase in fine particulate, fire is going to increase, dust is going to increase. The emissions from plants are going to increase unless those plants die because of climate change. And the soil is going to emit more nitrogen under warmer conditions. The decrease, some aerosols will evaporate under high temperatures, so that will cause a reduction. And then it's just how much of each factor is there going to be, and then the big uncertain factor is wet removal or rain. Right after a rainstorm, you go outside and the air is really clean because the rain did that. It washed the air. Those particles get hit by the raindrops and end up in the rain runoff. So, have more frequent rain, you get cleaner air, even when these sources are going up. If you get longer period, it's known that in the Midwest, we're going to have more intense rain. But the key thing for air pollution is how often. If you go 2 weeks without rain, the air is building up all its pollutants, and then it gets washed out. So it's that interval, and that interval is really hard to predict going forward. And the caveat is wildfire is becoming sort of the 500-pound gorilla. If wildfire goes up, then these factors are too small to matter. It's just wildfire makes smoke. Wherever it blows, there's going to be smoke. You know, the official IPCC 6 that came out in 2021 was pretty conservative about how much fire is going to change. And that is changing, right? So the papers that are being written now and the simulations that are being done now that are going to be in IPCC 7 in about 3 years, right? I think the community will have done a better job saying, here's our best guess at where fire is going in North America. And then we're going to see new ozone and new particulate matter numbers that are a little more on the upside and not so much of this, maybe up, maybe down. That's my guess. I very well could be wrong. I would not be surprised at all if I'm wrong. And then just to show you that fire has been increasing, I thought I'd work myself out of a job. I'm an air pollution particle guy, and it had been decreasing since 2000 all over the country, and then it plateaued in 2016. And nobody wanted me because nobody was polluted, right? And then if we look at what's caused that plateau, this is the wildfire signal measured by soot at monitors all over the country. I just averaged all the monitors that had been put in place since 1988. We see the decrease because we were cleaning up diesel. We introduced clean diesel, and factories either cleaned up or went offshore. And those two factors were taking soot out of our air, and fire was fairly constant during that period. And then the last 6 years have been horrible fire years in North America. And so the soot has been increasing at these monitors. This is 2023 Cedar Rapids. It's kind of a complicated graph. I'm going to walk you through it. This is the start of 2023, and this is a count of the number of bad air days. And so you go 0, 0, 0, 0, 0, 0, and then middle of May, you get 3 bad air days. And then a few more at the end, and then June was really bad and July was bad. For a total of 17 bad air days in Cedar Rapids 2023. This gray line is the 5-year average. 2 bad air days a year in Cedar Rapids. I had worked myself out of the job, right? And the orange is the maximum in the last 20 years. So this is the worst year before 2023 back to 1993, or I don't know, doing my, no, 2003. So the worst was, 12 bad air days. Back to 2003, and beat that by a long margin. You see most of them occurred in the summer. So, and the same story is true throughout much of the Midwest and the Eastern US for 2023. And I took some photos. This one was from the parking garage, the old Capitol parking garage on June 15th. And this was at 74 micrograms per cubic meter. The new standard is 9. So we were at 6 times the standard-ish. And visibility was about 2 miles. And this is on a much cleaner day. It's 8 micrograms, so this is below the standard. This is the screenshot from my computer. I was looking around at the different Iowa DNR monitors. This was in Waterloo, and they hit 165 micrograms per cubic meter, which are values that we associate with the Western US during fires, or with polluted megacities in Africa and Asia. This is not a US number in the Midwest, right? And the health-based limit for a 24-hour period is 35, and for the annual average, it's 9. So you can, those would be here and way, way down here. The literature says this is going to become more frequent. It's not going to be a 2023 every year. Thank goodness, but it's going to be more 2023-ish going forward because of more fire and more smoke. The literature is clear on this. We did fire suppression for 50 years in Canada and in the US. We didn't allow things to burn because we didn't want structures and people and valuable timber to burn. So you put out every fire. At the same time, climate change is creating conditions amenable to fire, right? Drier and hotter. And you have pests that are coming in and causing large-scale diebacks, and that wood is very prone to burn. So the air quality models run on reasonable future climate smart, or climate aware models of how much fire they're going to be, have longer fire seasons, more smoky days, and more intense smoke on the smoky days. And in many places, air quality management is now becoming just smoke management, because we cleaned up all the other sources. In the Western US, 16% of the particulate matter is from smoke on average, but on the bad days, it's 70% wildfire smoke. So it's less about chasing auto exhaust, which is what it was for 30 years, and figuring out how to get every large electric power station to install scrubbers to clean up the air. It's now about educating people about what to do on when the smoke comes from these large scale forest fires. Any questions or discussion about that stuff? Yeah,
What about methane? Is it a factor?
that's, are you a plant? Methane is in my win-win combinations.
All right.
So, yeah.
I just wanted to ask, I know a long time ago, they said we had a hole in the ozone layer,
Uh-huh.
and I find that the different countries took all these steps, and then suppose they got better, but you never go back to being worse again.
No, the hole in the Antarctic ozone hole appeared in the early 1980s. It is caused by refrigerants that contain chlorine, so Freon. We didn't know it. It was the wonder chemical, right? It was safe, you could breathe it, it didn't burn, it was non-toxic, it was more efficient than the refrigerants that came before. It allowed everybody to have refrigeration. And you know, it's probably, if you made a list of the top 10 inventions of the 20th century, it's in there. What we didn't know is that chlorine was going to the stratosphere, way up high, being liberated and then chewing up hundreds of ozone molecules for each chlorine. And then, because of a weird Antarctic weather phenomena that happens in August, September, October, all the ozone over Antarctica got chewed up. It would go to zero. There would be no ozone left. And so it's a big success story. All the nations of the world got together, for the scientists, for the chemical companies, and said, we're going with the scientists. And by the way, the chemical companies said, our patents already ran out on all these chemicals. We have substitutes that won't chew up the ozone layer. We're on board. So all the chlorine containing refrigerants were banned. Substitutes without chlorine were put in place. And the ozone hole is getting smaller each year. It is not gone. So the ozone layer did recover, is recovering, and is forecast. The models show a full recovery in about 2040. Just takes a long time to cycle all that stuff through the stratosphere. There is some cheating going on. And that tower I showed with the measurements, that's the cheating detection system. It's not our station that detects the cheating, it's stations closer to the cheating. And the cheating happens to be in East Asia. So it's Pacific stations will catch a whiff of this chlorine containing gas and say, hey, this was banned. And we've used almost all the legal stockpiles. That's my ozone hole story. So climate forcing agents, things that affect the climate, we put them in two bins. Long-lived forcing agents like carbon dioxide and nitrous oxide with lifetimes of 150 and 114 years respectively. And then we have our short-lived climate forcing agents. And there's three of them that are potent air pollutants. And so if we clean up these three things, we're fixing a climate problem and we're fixing a health or air pollution problem at the same time, which can enable a lot more people to get on board with the solution. Also, because they're short-lived, you stop the emissions, the atmosphere changes quickly. You get a fast payout, which is good for health, right? People don't want to do an expensive fix and then wait 20 years for it to show up. And we need climate fixes that are fast. We need to do both the slow and the fast climate fixes. We need less CO2 and less nitrous oxide emissions, but that's to protect our children's grandchildren in 2100. To protect the species now that are going extinct on mountaintops, we need temperature reduction now, and you're gonna get that from controlling these short-lived forcing agents. One of them, black carbon, Greg Carmichael, University of Iowa, is the loudest and oldest. It's not that he's old, he's been saying it for a long time, that this would be a good thing to control black carbon. And then Greg's student, Marcelo Mena, you may have seen his public talks, former environment minister, so PhD, University of Iowa, environment minister of Chile, Chile's negotiator of the Paris Climate Accord, and currently head of the Global Methane Hub, is aggregating philanthropic dollars from the Gates Foundation, the Jeff Bezoses of the world, to try to come up with money to get methane out of the atmosphere now. And tropospheric ozone is a warming gas. It is a greenhouse gas. And so lowering its concentration is a good thing for health, for crops, for ecosystems, and for climate. Yeah.
What are volcanic eruptions figuring here? I got kids who live, on the shoulders of, and we lived on the shoulder of, and there were times when it was not safe to go outside. Or is it too minuscule to even make it?
So volcanoes cause air pollution problems, particles and sulfur dioxide and hydrogen sulfide, right? And so when Mauna Loa erupted, the Hawaii Department of Environmental Protection and the EPA, they were flying drones and trying to figure out where the sulfur plume was and could people shelter indoors or did they have to evacuate? So all of that exists, along with the other hazards of the ash and the magma. So, and then from a climate change perspective, when there's a massive eruption, Pinatubo, like Mount St. Helens wasn't big enough to affect the stratosphere. But Pinatubo was, the big eruption in Tonga 2 years ago was. So those are strong enough to punch through the stratopause, the tropopause into the stratosphere. Once the pollutants get into the stratosphere, they stay there for about 4 years. And so it's an injection of water vapor, which chews up ozone, and sulfur, which causes particles. And both of those are cooling to the planet. So you get half degree of cooling for a big eruption, and it lasts about 4 years. So then the other part of the story is scientists see, if we put a lot of sulfur in the stratosphere, we get a little bit of cooling. So sulfur geoengineering. So let's load up planes with yellow sulfur, fly them in the stratosphere and just dump it out. So that's a real thing. And it's the cheapest way to cool the planet. And so people are afraid that, because you could start doing it for $500 million, right? And $500 million to, who's the Twitter guy? Musk, Elon Musk is like, I wouldn't put it past them to just start doing it and say, stop me. Right, I'm gonna save the planet. So what scientists are doing is saying, let us do it in a controlled manner so that we can figure out all the unintended consequences that are going to be associated with these geoengineering solutions. So we could stop. I have my 5 tips.
Let's do the 5 tips.
Okay. All right, 5 things that EPA did not say strong enough. Number 1, if you have supply, be ready for a smoke event. The new term is a smoke wave. You have heat waves, you're gonna have smoke waves, 2 to 4 day period where it's not so great to go outside. So you need to be prepared. If you use supplemental oxygen, you need a supply of it because you might not be able to get it. Make sure your medication is, you have enough for that smoke wave. Have a plan to access care if you experience symptoms, right? And that's gonna depend on, how do you get to the doctor? Do you need a ride? Who's gonna take you? All that stuff. Shelter indoors. The EPA is very clear about this. If it's bad, shelter indoors. But what they don't say is there's a right way to do it. And that is close the windows. If you have a whole house fan, these are usually in your attic and they suck air from the lower floors and blow the hot air out of your attic. You don't want to use that during a smoke wave because it's going to force infiltration of that smoky air. You need to set your air conditioners, if they have this setting, to like always run the fan. You want to be pulling air mechanically and running it through your filters. You have a furnace filter. And your portable window AC units have filters. And you want to force the air through that filter as often as possible. And you want to use the best filter that you can afford. So if you're trying to protect yourself from smoke days, the $16 3M filter that's like this and in the pretty package is worth it relative to the no-name fiberglass one with the brown cardboard that's $1.76.
Yes.
Number 3, if you have a portable air purifier, the smoke wave is the time to run it. There's one there.
Are there different kinds?
There's like 230 different ones on Amazon right now. If you're concerned about buying the right one, you're happy to field emails about that. I would. There were some crack products that were put out during the pandemic. Look for the clean air delivery ratio catered. And I forget the magic number of what cater you need. And then watch for the filter costs, because some of them are like $30, but then it has a $45 replacement filter. So you're better off getting the $100 one with the $25 replacement filter. Number 4, your COVID mask. An N95 respirator works against smoke. It's the same size particles from the virus particles when they're enveloped in lung fluid and mucus. That's the same size as the smoke particles. So the same masks work. If you look at picture in Asia, people have been wearing masks against air pollution for 15 years now. And then organizations need a smoke plan. Schools, youth camps, daycare, elder care, football camp, cheerleading camp, right? Those school administrators and coaches and volunteer leaders need a written plan that says, if we get air quality index of 150, what are we going to do? We cancel? Do we delay by 4 hours? Do we tell the kids to wear masks? The easy thing is, if it's kids, you're going to have their medical information on file if you're running a big event. That's going to indicate whether they have an asthma management plan. And everybody's got to review those asthma management plans and make sure that we really have all the medication for all those kids. Because those asthma management plans go from being a little footnote in the folder to a really life and death kind of thing. So, local, the county public health people want to help. And they will help any of these organizations put together a plan and make that day before and day of call. But you need to build a relationship with them. You call them up and say, hey, I'm doing a football camp for 400 boys this summer. Charlie Stanier said I need a plan, you help me write it. And I know the Johnson County and the Lynn County Public Health people would be like, thank you, that's why I do this job. And I have my choices. Yep.
If we go back, when you said that, and asked about VOCs, and you said that human-made VOCs are only 5% as compared to plant VOCs,
Yes.
are you talking pollen, or are you talking other kinds of chemicals? What is it?
Volatile organic compounds,
Yeah.
so, plants emit isoprene, monoterpenes, and sesquiterpenes in very large amounts. So globally, when you add up all the human emissions of gasoline vapor and diesel and solvent use and industrial emissions, you get, I think, I know the nature number is 142 teragrams. The human value is 5% of that. Now, when you go to summertime in Chicago, it's not 20-to-1 anymore. It's more like 1-to-1. Right? Because it's just a lot of people, not so much vegetation, so the local environment is more balanced. But then as soon as in the afternoon, the air starts blowing in from Wisconsin, then it's going to be shifting to more of the plant, vegetation dominant emissions. So this is really important for ozone and for fine particulate matter. But the monoterpenes, sesquiterpenes, and isoprene are not toxic. Right, many of the human emitted compounds are,
Yeah.
and so just from protecting people, like you don't want to breathe gasoline vapor. Or any of the other air toxics that are out there. Well, thank you so much for all the great questions.